we will be first be hearing Sarah Lieberman, but I let my colleague Hugo Peter introduce this roundtable, and we will hear Sarah Lieberman just after.
Yeah, ladies and gentlemen, thank you for attending to this conference. Maybe we have a little delay, but let's talk of Quart d'heure Lyonnais. It's a real pleasure to be here to take part of this conference. I want to warmly thank all the EESD team, especially the team who organized the conference. Thanks for the Space Week and thanks for the invitation. It's an honor to be as moderator of this high-quality panel. Only women in this panel, but it is for the best, and it will be good to hear them. The objective of this second roundtable will be to analyze the comportment of the member states and to see if the approach of these member states is convergent in terms of spatial trajectography as part of the EU SST architecture. Firstly, let's begin with a presentation of Madame Sarah Lieberman. She holds a PhD in European law and is now professor of political science and international relations in the Christ Church University of Canterbury. She will talk about Brexit, and we will see that it is not inconvenient, and the effects of the Brexit on the orbital management's European policy. So, Madame Lieberman, the floor is yours.
I just want to say thank you very much for inviting me. I'm sad I can't be in Lyon with you today, but I'm glad I've been able to join you online. So today, as you said, I'm going to be talking about SST, SSA, and actually the place that Britain as an ex-member state of the EU takes here. So we'll get into this just now. So what are we talking about here? I'm sure I'm talking to people who presumably know quite a lot about SST. I did sit in on a couple of the sessions this morning and there was an in-depth discussion of SST. So I'm probably preaching to the converted, as they say. But what we do, what SST is required for, is to watch out for objects in space. So there's an estimated around 23,000 pieces of debris, bigger than about a softball, about that size, in space at the moment. And the speed that they travel at makes that very dangerous. Now, until recently, this perhaps wasn't such a problem. Largely, it was a hypothetical problem. What could happen if space debris became too much? However, what we're seeing now, and especially after yesterday, which I will come to in a moment, is an increased risk to satellites, a much increased risk. One of the reasons for this is that satellites have become much more important. They've become more important to states, to bodies, to international relations, and to individuals. And also because there has been an increase in the actual physical damage being caused to satellites by those objects orbiting the Earth. Now, if we're looking at collisions or what we term near misses, we see that there was 2,000 reported near misses in 2017 a day. We're now up to 4,000 a day. That's only 4 years ago. That's doubled over 4 years. Now, if this was to continue, we would be looking at an incredibly dangerous situation in the near future. So, doing this space surveillance and tracking is incredibly important for states. And what I want to look at here is who does this tracking and why. Okay, so it's vital to ensure the security of our space hardware, not just at the state level, but also at the commercial level. And this is where we begin to have slight, not necessarily difficulties, but the market state matrix comes into play here. And we begin to ask, who should be paying for this to be tracked? How should it be monitored? And who catalogues the information at the end? Commercial entities who might be launching satellites or indeed ensuring the launch of satellites, it's very important for them to understand the risk that is posed to satellites. So those insurance companies and the commercial entities themselves will need to be able to look at the catalogue of risk, to use actuarial studies to understand whether it is worth sending their satellites into orbit, or indeed how much insurance will cost for sending satellites into orbit. If we're going to look at this from a security perspective, then security theories and realist security theories would suggest that as soon as we have something worth protecting, we need to up our security game. So if you have nothing that requires a level of security, you will not pay for that security. You will not analyze the risk of something happening to it. States are realist actors, and they will act, and they need to act to protect their own assets, because as we know, it's a self-help international system. There is no enforcement of international rules that states have got to abide by. And this is a problem for space, and something that's going to keep coming up again and again. This is an issue that we were discussing last week in Rome. I know that Mariel was there as well, and I'm sure this will be something that comes up on this round table as well. As soon as states or commercial entities have assets in space, it becomes necessary to track any potential threats to those assets. Now, the threats could come from the space debris that we're witnessing. Threats might also come from other states or other entities. And this is something that we have seen, as I say, this week, looking at the Russian anti-satellite test that has taken place. So we're looking there not just at debris as a potential problem, although it is a potential problem, but we also need to look at the other states and how they are acting in space and from Earth to space. As soon as states have security assets in space, they can no longer trust another state to monitor the situation. And I think this is what we've seen recently. This is important when we look at the European Union and the European increase in monitoring of space. So the EU has very much increased its SST capabilities in the last few years, largely because it has hardware now to protect, and it needs to do that. And in this self-help international relations system, Europe can no longer trust the USA to do that for them. Now, we often think that our main issue is to avoid the Kessler syndrome. And of course, this is true. And this is still in the background from the film Gravity, which illustrated the importance of the Kessler syndrome. That would mean that suddenly low Earth orbit becomes too dangerous to pass through. It becomes completely unusable. Now, to avoid that, we do need to track satellites. We need to track satellites that are past their useful life and could disintegrate. And of course, we need to track space debris. However, it does not take the Kessler syndrome. It does not take that level of complete destruction of low Earth orbit to cause great disruption to satellites. Now, before we reach a state where we could, where we would note the Kessler syndrome and note that we have reached a stage where this can't be used, we will find that operational satellites will suffer constant hits. Satellites will not function properly. Satellites will need to be manufactured in a different way to avoid hits, perhaps. And we will note a large level of disruption to individual lives, to state behaviors, because remember, these satellites are not just there so that we can monitor our daily commute via Garmin, not there so that we don't get lost when we are driving to work. These are also military satellites that need to be protected. Without the rules in place, we will see an increase in debris, and simply tracking that is probably not enough. We can track it, we can watch it increase. I think we're reaching a stage where we need more than that. Now, this was from yesterday. So this was part of a Twitter feed that I was reading yesterday. Not only are we now seeing extra satellites, small satellites, for instance, the Starlink constellation, which is increasing traffic in orbit hugely, particularly in low Earth orbit, which has resulted in a huge increase in near misses of satellites. But now we're also seeing increase in debris, as we say, from yesterday, the Russian anti-satellite test, which appears to have taken place either on the 15th or the 14th of November, and has created a cloud of debris. Now, yesterday they were saying that 14 pieces of debris had been tracked so far, but by today it's looking a lot more like a cloud of smaller pieces of debris. Now, simply tracking debris in low Earth orbit can perhaps help. I know the International Space Station is able to put measures in place to remove cosmonauts and astronauts to a safe area, but tracking is not enough to prevent this happening. Who does the tracking? Interestingly, as I said, we have US does space tracking. It does SST and has done for a long time. It was part of the Department of Defense. It's now part of the United States Space Command, okay? They now have this space fence radar system, which is developed by Lockheed Martin, cost 1.5 billion, and they can track items down to the size of a marble. Previously, they tracked items the size of a softball, which is about that size. They've reduced it to this size. Traveling at the speed that they do, the size of a marble, or indeed a fleck of paint, can cause huge damage. Now, what's interesting about US space tracking is that it's actually available to everyone. The Pentagon is in charge of this, and yet coming from the United States, where there's no universal healthcare, they complete space tracking for everyone. So this has been very important. However, as I said previously, in this realist self-help system that we do apparently still live in, the European Space Agency, as it has developed more and more hardware in space, and the more it has something to protect, the more it needs to track those dangers itself. So the European Space Agency, the SST team based there at ESOC in Darmstadt, Germany, they work closely with the member states to use the member states' own hardware, to use the member states' capabilities to track what is happening in space. As you see here, this is where all the different points are. There's the lasers, those are the ones in pink, radars and telescopes, which help with the space situational awareness and the space surveillance and tracking. Now, this is all based on Decision 541/2014 in the EU, which developed the framework for doing this. Now, 7 member states are most closely involved in this: France, Germany, Italy, Poland, Portugal, Romania, and Spain. And they work together to provide the SST cooperation for Europe. Now, it is a mixed market. As I was mentioning before, space has become much more of a mixed market. The matrix of state market, certainly in the satellite industry, has become very closely entwined. Now, this means that in terms of SST, in terms of surveillance and tracking, we have commercial organizations involved in this as well, not just the state-based entities that we might expect. So this is a list down here, which hopefully you can see here. Lockheed Martin at the top there. They collect the data, they catalogue the data, and they provide information. They're based in the USA. So it's not just the national space agencies that track information, there are commercial entities as well. In terms of civilian, we're also looking at, as I said, the Pentagon largely. Now, where is the UK in all of this? Since Brexit, we find that the UK tends to be in between decisions on most issues. The UK has been trying to figure out its policy basis alongside the EU since deciding to Brexit. The UK keeps coming out with sort of a slightly vague statement. The UK welcomes the agreement that UK users can continue to access EU space surveillance and tracking services. That's great. UK also continues to receive space surveillance and tracking data from the USA. It's in between. So the UK at the moment is trying to come up with its own system. It is looking to different companies, different research consortia to draft documents and draft reports on the kind of surveillance and tracking system that would best serve the UK. So as we stand at the moment in the UK, we're what we might term betwixt and between. We are writing reports on ways that the UK could do this alone, and yet
recording in progress.
Still relying on the EU for its SST and also the USA. Now, I would say more importantly, perhaps than looking at the different member states and how they implement SST is the question of international regulation. While tracking is important, obviously, and as we have seen in the last couple of days, by tracking debris and by tracking dangers in space, we can ensure that astronauts, cosmonauts, the International Space Station are perhaps safer than they would have been otherwise. We also note that tracking is not enough to prevent debris from being created and to prevent dangerous situations from occurring in space. We're reaching a point where we might say that the carrying capacity of low Earth orbit is reaching a high level. At the moment, we're carrying out a process of observation rather than regulation, because regulation at the international level is incredibly difficult to do. In regulation at the EU level is not so difficult. We have the overarching power structures of the European Commission, that has enforcement ability, has enforcement capabilities. At the international level, we have to rely on soft law and the interpretation of the states that are members of any international agreement. The problem with space, of course, is that being a common area means that it is open access and we cannot restrict launches particularly easily. There are possibilities. These are possibilities that we discussed last week in some depth in Rome as well. The idea, perhaps, a tax on launch, tax on satellites, or international regulation based on rules and soft law. The problem with either of those possibilities, of course, is who enforces, who collects the tax, or who enforces those laws on the international stage, given, as we said, that it is a self-help arena rather than an enforced hard law or national law area. So what could happen now? We might discuss reduced launch rates as profit margins drop. So as low Earth orbit does become more crowded, it's more likely that we will see collisions occur. As the risk increases, there is a high chance that there will be less profit-driven desire for commercial entities to launch satellites or to go into space when that risk becomes higher. To reduce the launch rate, we do need to see profits drop, because where there is profit, commercial entities will seek that profit, and space currently is too profitable for us to be easily able to reduce the launch rate. There is the option of tax. To achieve an optimal capacity, we're going to need to make this more expensive. There is the question, of course, though, of how much is too much, what level of tax, who gets to decide, and who collects the tax. The final option is the international regulation option. Can we and should we use international tools to ensure that the capacity is not overrun, that collisions do not occur, and to enforce behaviours in space and towards space that allow everybody to use space in the way that was set out in the UN treaties for all mankind? And certainly watching what has happened this week with the anti-satellite tests carried out by Russia, we have to ask, can that be allowed to continue? This is not for all mankind. This is not the safe use of space. This is basically an act of aggression. Who should be there to enforce the regulation that says we cannot do this? And that's the end of my presentation. Thank you very much for listening. I'll pass over to Mariel for her presentation now.
So thank you for your presentation.